As we move into Chapter 2, which is all about probability, we are going to occasionally encounter some very large numbers and some numbers that are very close to zero. When that happens, our calculators will oftentimes express the answers in scientific notation, because scientific notation is a much more compact way to write out the answer. Scientific notation is also helpful because it allows us to understand the magnitude of a number, right? How really large or really small the number is without having to count up a bunch of zeros. So for example, this number here, 123 followed by 3, 6, 9, 12, 15 zeros, okay, would be expressed in scientific notation as 1.23 times 10 to the 17. Whereas this number, 24 followed by 3, 6, 9, 12 zeros, would be expressed as 2.4 times 10 to the 13. And comparing these two numbers, it's much easier to see what the relative magnitude of the numbers are, right? We don't have to count up a bunch of zeros in order to see that this one is going to have not exactly 17 zeros, but it's going to be of a magnitude on the order of 10 to the 17, whereas this one is going to have a magnitude on the order of 10 to the 13. So it gives us a way to easily see the magnitude of really large or really small numbers. That said, sometimes it's helpful for us to take a number that's written in scientific notation and put it back into standard notation. And so here's how to do that, right? If you're given a number, a times 10 to the nth power, and you want to change it back to standard notation instead of scientific notation, then what we'll do is we'll move the decimal n times to the left if n is positive, the decimal on a, right, 10 times to the left if n is negative, and we'll move it n times to the right if n is positive. And then we'll just drop the times 10 to the n. So let me just give you a couple examples of that. If you typed some big thing into your calculator and you got 2.731 times 10 to the 15th power, that's the scientific notation of the number. If you wanted the standard notation, then what we would do is we would take this decimal point and we would move it 15 times to the right. So we move it 1, 2, 3, and the decimal point would end up there. And then we're going to have to move it 12 more times so that in total we will have moved it 1, 2, 3, plus 12 equals 15 times. So what that means is we're going to end up having 12 zeros after the 1. So this would be 2, 7, 3, 1, and then 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can come back and put a comma after every 3 places, and that's what that number would look like in standard notation, right? So this huge monstrosity of a number. Similarly, 5 times 10 to the 13th power would be, well, right now we just have a decimal point right there. If we move it 13 times, we're going to end up with 13 zeros. So this is going to be 5 and then 13 zeros. 2, 3. So it's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? If the exponent is a negative number instead of a positive number, then this is indicating that the number, instead of being a very big number, is actually a very small number. And what we do is we move the decimal this number of times to the left. So if I have 3.2 times 10 to the negative 12, I'm going to take this decimal point and I'm going to move it 12 times to the left. So the first time I move the decimal point, it'll just end up right here. But then I need to move it 11 more times. So I'm going to get 11 zeros and then a 3, 2. Okay, so this would be 0 point, and then 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then a 3, 2. Similarly with this number here, Again, there's not a decimal point written, but it's assumed, right? 7 is the same as 7.0. And if I take that decimal point and move it 9 times to the left, I'm going to move it once, and then I need to move it 8 more times. So I'm going to get 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, and then a 7, right? So this is how scientific notation works. Let me just give you a couple more examples, just showing you where this might come up in an actual calculation. So let's say for whatever reason that you needed to perform the calculation 14 to the 11th power divided by 6 times 5 times 4 times 3 times 2. Let's see what we get. So I'm going to do this in my calculator. I'm going to give myself a little fraction so that I can do 14 to the power of 11. Okay, and then arrow down and do 6 times 5 times 4 times 3 times 2. Whoops, times 2. And yeah, you'll notice that Desmos gives me the answer in scientific notation. I was asked here to give the answer in scientific notation, rounding A to 2 decimal places. A is this number right here. So I'm rounding that to 2 decimal places. That's about 5.62. Times 10 to the 9th power. Okay, so there's my answer. Now, we're also asked to rewrite that answer in standard notation. So in standard notation, I would take this decimal point and I would move it 9 times to the left. So there's 1, 2 times, and then I need to move it 7 more times. So I'm going to get 7 zeros. All right, so I'll have 5, 6, 2, and then 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, so there's my answer in standard notation. Now the same thing might happen if I have a really small answer, like if I needed to do 2 divided by 10,317,437. So in my calculator, this would be 2 out of 10,317,437. And you'll see once again that the Desmos calculator gives the answer in scientific notation. Rounding that to 2 decimal places, it would be approximately 1.94 times 10 to the negative 7. And if I want to give that answer in standard notation, I need to take this decimal and move it 7 times to the left. So the first time I move it, it ends up here, and then I have to move it 6 more times, right? 6 more times to the left, so I'll have 6 zeros. 1, 2, 3, 4, 5, 6, and then a 194. Okay, so scientific notation.